Yeah, my name's Jacob. This is Speculator. So gonna assume you know the problem with latency. So here we have various techniques to deal with that. We have the static method where we're doing static compilation. We have the manual precompile calls, which we don't really want to deal with ever. The very popular precompile tools, and then this other category, speculative, where we have precompile signatures and speculator here. I will say precompile signatures predates speculator, and I found out after I was mostly done. There are some differences, but I encourage you to also check out that package if you're interested in this one. Yeah, so here's a single line of code. This is the package precompilation for speculator. It's niche in its use case, but we can kind of get into why soon. And this is the main function that you're going to be interacting with. So we have the main speculate function, and you give it a value. This value can be a module or anything callable, and it's going to search that for methods that it can just compile. And during that search, you might want to avoid certain names or types or modules or whatever, so you can provide this predicate, which allows you to skip that. These other commands lets you run it in the background fed. You can do a dry run if you set compile equals false. We'll go into limit shortly, but that prevents you from generating methods with too many concrete specializations. If you set the path to anything, it will write these directives to the file, and the verbosity is just the logging behavior. So it only depends on interactive utils, so loading time's pretty fast, and so we're gonna define a method. We can handle abstract types and union types, but not union all types. And so if we call speculate on that with the limit is 2, then you can see it compiles both of those individual specializations. If we'd set the limit to 1, then that would exceed it, and it would do nothing in that case. If we call it again, this time we provide a filter. You can see that it's not identifying the string method, and it does identify that the method with char is already precompiled, so it's it tells you it passed on that one. The searching itself is fast, so with every single loaded module in Julia, it will search all of them in less than 2 seconds in this particular example. So your real, the performance bottleneck is just compilation itself. If someone has performance problems, I'm sure there's ways we can optimize it, but it seemed like a minor concern. A novel feature that we implement is here. So I think at the REPL we have a lot of time where we're not actually doing anything. We're typing, or we're thinking, or petting a cat, and I think a REPL can use that time more efficiently. And so it'd be nice if we just hit enter and it compiled. So you can do that here. Will that save you time? Probably not. Do I think it's cool? Yes. If you can think of a smarter thing to do with all of that idle time, let me know. I think that would be cool. So the next couple slides are going to be pseudocode of just the general algorithm that I'm using to identify these compilable methods. So if we get that all modules value I showed, we search every loaded module. For each module, we search every name and value within it. First checking the predicate. And then every time we get anything else, then we generate the compilable methods from that. In the signatures, we'll get into find types soon, but we get the Cartesian product of the concrete types of the methods, and then we check the limit. If it exceeds the limit, we ignore it, we move on. Otherwise, we'll process the signature, which most of the time will be called to the compilation or the logging. This finding types, if it's concrete, then we're good, we just keep that. If it's annotated with no specialize, then that's also compilable, good, we keep that. If it's union all, we don't want to handle that. I don't know how to handle it, sounds like a lot of work. And For abstract types, like I mentioned, we also filter those on the predicate using the module name and the name of the type that you're getting it from. Yeah, so in conclusion, you can use this as package compilation. I would say not very often. If you're just getting something set up, you want something quick and dirty, go for it. It's not going to add loading time, and you might catch some like strongly typed methods you put there. If you have a bunch of dynamic, like abstract methods, this is not going to be very helpful for you. You can also use this in your startup file. Yeah, that's all we got. Do we have any questions?
Question.
Thanks. First of all, not a question, but Tim, 2 years ago we talked about it'd be really neat if someone did this. So thanks for doing this.
I think I saw that issue, right?
I might have been, yeah. Yeah, thanks for the talk. I had 2 quick questions. One was, do you find an issue with the fact that precompiles are entry points, usually for dynamic dispatches, and many entry points may be statically reachable, and so like, do you end up with redundant code problems where like if A calls B calls C calls D, and then you end up precompiling all of those, but you could have just precompiled A, then do you get like redundant code in there? Is that an issue?
I have not measured that, and I believe there's some internal behavior that can very quickly just tell me, no, this is already done. If you run this with compile on, and then you run it a second time with like if you do it on base, the second time will go super quickly. But perhaps there is some gains to be made there.
Cool, no, that's great. And the second question was just, is it possible to generate entry points for trim rather than just precompile statements?
I have no idea.
Okay, cool, thanks.
Thank you.
Any others? All right. Well, so I'll ask. So I guess the issue that Nathan was asking is about the redundant ones. It's presumably just the level of almost the text parsing, right? Because you won't compile anything more than you need to, right? So in other words, if you compile a method and one of its callees, but inference would do that for you, that second precompile statement will essentially take no time, presumably, right?
I don't know, one end of generating like an entry point to the second one also?
I mean, so precompile just does the...
If it's a real call, then basically like the compiler caches it anyway. So the compiler is already doing the caching behind when you call compile or precompile on some. So if you call precompile twice, the second one does nothing. Well, it doesn't do nothing, but it's basically nothing. So there shouldn't be any issue if you do like compile A that compiles B, and then you do compile B. It's going to take like a microsecond to check, oh, I'm already being compiled, but there shouldn't be any issues. And regarding it about the native code, if the code doesn't get inlined on A, then yes, there's already a native code. But for example, if B was inlined in A and you asked B to be precompiled, it might be that you also now generate an entry point into B. It's a little questionable if that's worth it or not, and there's some heuristics that work around this, which are not great, so your mileage may vary.
All right. Well, just for reasons of time, we should move on. Thank the speaker again.